Okay, so here's a video on solving systems by graphing. So here's a couple of equations that were given here, and then we'll graph them to solve them. When you're doing this by hand, it's very, very important to get the graph as exacting as possible because you're going to be visually inspecting it for the answer. If they do intersect and they're not the same line, you're only going to get one answer, and that answer will be shifted depending on how well you can graph it. So obviously, if I don't graph it correctly, I'm going to cheat and I'm going to know the answer because, well, there are other ways. Okay, here we go. All right, we'll call this number 1. We'll call this number 2. You can do them in lots of different ways. When they're in the standard format like this, and just as a reminder, standard form is ax plus by is equal to c, where a, b, and c are real numbers. That's the standard form. We also have the slope-intercept form, y equals mx plus b, where the slope is b, or wow, the slope is m, and then the y-intercept is the point 0, comma b. And b will take on the sign of whatever's in between x and b. So if it's like, 2x minus 1, then negative 1 will be the value of b. So it'll keep that sign. Okay, here we go. I'm going to do this 2 different ways. It's looking like they're both kind of nice as far as just using the standard format, but I'll actually graph them in 2 different ways. The first way that I'm going to graph is I'm going to take number 1, which is 2x minus y is equal to 4, and I'm going to make what's known as a t-table. I'm going to choose a value of x or y, and then I'm going to find what the other one must be to make this a true statement. So here we go. Here, and unfortunately I can't do this as a visual thing, but oh man, I wish I could. That'd be cool. I need a paper. Piece of paper. I wonder if I can make a piece of paper. Nope, this is not going to let me shrink it any more than that. Okay, well, that's unfortunate. I could really use a smaller window. Let's see. I wonder if I could do this. If I can make this really, really, really tiny. Nope. Okay, well, I can't do that. That's unfortunate. All right, well, you'll just have to visualize it. Anyway, if I choose x to be 0, then that means that I could effectively cover this up because 2 times 0 is 0, which means it never was really there. Now I have negative y is equal to 4. I can just divide by negative 1, or I can multiply by negative 1. It doesn't really matter. But that's the effect of making x 0, is you can take a thumb and just go and cover that whole term up. So when that happens, this goes to 0, then that means that negative y is equal to 4, and dividing by negative 1 will give us y is equal to negative 4. So the corresponding y value is negative 4. That's one of the points. 0, negative 4, 1, 2, 3, 4. I'm also going to do the second point in yellow because I'll do this entire equation in yellow, and then the other equation I'll probably do in like blue or something. Alright, so now I could choose another value of x, but in this case I'm going to go ahead and I'm going to choose y to be 0. This is essentially where the power of it comes in, is you can make one 0, find the other one, make the other one 0, find the first one. So I'm going to make y 0, and when y is 0, subtracting 0 doesn't do anything, and so what I end up with is I end up with 2x is equal to 4. And then I divide by 2, and I get x is 2. So the corresponding x value is 2. So the point 2, 0 is the x-intercept. And then from here, because 2 points determine any unique line, at least in 2 dimensions, I can just go ahead and connect the dots and sing the song. Now what I am going to do is I'm going to make a third line here, or a third point here, and I'm going to use the slope in between these points. I noticed that to go from here to here, I have to go to the right, or to the left 2, and then down 4. So I go from here to here's left 2, down 1, 2, 3, 4. So there's another point on that line. So I'm going to use that to draw my line, make sure I get it as straight as possible. All right, so here's my line, and now we'll move on to the other one. Now for the second For the second one here, number 2, 3x plus y is equal to 6. I'm going to go ahead and I'm going to do this through the points or the slope-intercept form. So I'm going to subtract 3x from both sides. And when I do that, the y is going to be left alone, giving me y is equal to negative 3x plus 6. The 6 was positive here, so the 6 will remain positive because we didn't move it. There is no x term, so in a sense you can think of 0x minus 3x. That gives us our negative 3x. Now it's in the format that we have for the slope-intercept form, so we can read the slope, which is negative 3 over 1, and we also can read in the y-intercept, which is 0, 6. So 1, 2, 3, 4, 5, 6. And if I read the slope, it says down 3 and to the right 1. Down means negative towards on the y because the top is y, and to the right positive 1 because x is on the bottom. So positive x is over towards the right. So we're going to go right 1 and down 3. 1, 2, 3. And then I'm going to do that one more time. Over 1, down 1, 2, 3. Turns out that, wow, that point right there is our intersection point. We only have 2 or 3 options. They either are parallel, meaning they never intersect, so there's no solution. They are the exact same line. Wow, what in the world just happened there? That was interesting. Oh my lord. Oh boy. I lost it. It done went away. I'll have to draw it back in. That's so weird. Anyway, so where these two lines intersect, that is the solution. So we're going to take this point right here, which looks to be the point 2, 0. That's my intersection. So my answer is the point 2, 0. It's an ordered pair. Now, the way that you can check this is you just take those values of x and y, plug them in for each of these equations and see if it's true. If they are both true, this is the solution. If one is true and one is false, it is not the solution. So we'd have to go back and check ourselves. Plugging it into the first equation, we get 2 times 2 is 4, minus 0 is 4. Yes, it's true. That's good. And then on the second equation, we have 3 times 2 is 6, plus 0 is 6. Yes, okay, so they both work. This is the solution to this problem. So that's how you do it graphically. Again, the more exacting you can make your graphs, the better off you're going to be on your visual inspection. Later on in my classes, in fact, tomorrow, we're going to show you how to do this algebraically so you don't have to do it graphically. If you want to do this in your calculator, you'd have to solve each one for the slope-intercept form, plug it into your calculator, then hit, well, depending on your calculator, hit second and then trace for the calculate menu and calculate the intersection of those two graphs. When you do that, no matter which graphing calculator you use, your solution will come up as the point 2, 0. All right, thanks for watching. Hope this helped. Take care.